Welcome to this video series where we are going to be doing a grade 11 IT prac exam or paper 1 that can help you prepare for your upcoming exams. And we're going to be looking at the first question in this video, which is going to cover basic grade 10 work. So let's go have a look at question 1. So we have a scenario where we are hired to edit and create programs for a traveling circus, and the circus performs multiple shows that include acrobats, dancers, clowns, and contortionists, the people that can move their body in certain ways. And you need to help the organizers with software that manages ticket sales and display the show's details. So we're going to get into that. So let's do the first question, which is some basic programming. It's for 30 marks for a 150 mark paper. So 30 marks, that should be taking us around about 36 minutes to be able to do. I've opened up the question over here already. So we've got the data files. We're going to be working on that question first. So let's just double click on the code over there and let's go look at the question. Complete the code for the button Q11 that modifies the panel, the greeting panel, as follows. So we want to change it to that text, welcome to our circus. That's going to be the caption of the panel. Change the color of the panel to maroon, and we're going to change the text of the panel to white. And then when the user moves their mouse over the panel, enjoy the show must be displayed as a hint. There are 4 things and it's only 5 marks. That means one of these things is 2 parts to it, which I'm going to tell you now. It's that last little one, which I'll show you when we go into it. So let's go into it first of all. Let's do the 3 easy ones first. So first of all, we want to change panel greeting. So PNL greeting dot caption must equal to the text. We want to say welcome to our circus. Welcome to our circus. I think it was an exclamation mark. Circus. And then we want to change the panel to maroon, but the text to white. So the first thing is the panel greeting dot color must be changed to maroon. Now we don't have just maroon. There is no maroon. You're going to have to just go CL, which is the color maroon, which is a predefined color in Delphi. And then the text. So that's going to be a font property. So we're going to say dot font dot color, and that must change to not white, but CL white. So those are the 2 color changes. So those 3 things are very easy to do. Now the hint, enjoy the show. Now if you're not sure about properties of a component, you can just actually go to the design view and you can go click on the panel, which I think the panel greeting, if I click on panel greeting, which is that panel over there, you can go see all the properties over here. So let's have a look. We're going to look for hint. Now if you come, so you see there is a hint property. So it's simple. We're just going to change that hint property dot hint. We want it to change to what text do they want? Enjoy the show, exclamation mark. So we're going to say enjoy the show, exclamation mark. And if we run it like this, let's go test it quickly. If I click on the Q11 button, it changes it to maroon. Text is white and the caption has been changed, but if I move my mouse over it, nothing appears. And that's why it's for 5 marks. We've got 4 things here, but there's 5 marks. Why is that so? Well, if we come here to the properties of the panel, we know we saw that hint property. But in order for that hint property to be able to be displayed, I don't know if you know this, but if you scroll down, there is a show hint property which is set to false. And we only want that hint to be shown if this is true. So that's the 5th mark. So to get that 5th mark, we're going to say panel greeting dot show hint. There we go. Show hint. That must be changed to true so that the hint actually pops up. So let's test it now. So when I click on that button and then I move my mouse over the panel, you'll see enjoy the show as appears. Let's move on to question 1.2. Here we're going to do the code for the button Q12, which takes as input the number of adult tickets ordered by a spin edit and the number of children tickets ordered by a spin edit. And we need to work out the total cost for that particular order. So we're going to look at the on-click event, and it takes the time of the show via a radio group, and this calculates the ticket price. So the morning shows cost $150 and the evening shows cost $180. So there's a difference in the different type of show. Adults pay the full price while children pay 70% of the ticket price. But for every 2 adults, 1 child will be free. Now that's the tricky part. For every 2 adults, 1 child will be free. For example, if your order has 2 adults and 2 children, then you only pay for 2 adults and 1 child. But if there are 5 adults, then there are 2 sets of 2 there. So therefore 2 children will not have to pay. So there we go. So that's the logic behind that question. So let's just do the basic part first and we'll go from there. So there we can see the 2 numbers, and there we can see the radio group, which indicates the time of the show. And if I come here, we've already got the inputs done there. So now I actually want to work out which ticket price we're going to use. If we're going to do the 150 or the 180. So I'm going to create a variable for ticket, and it's going to be based on that radio group. So if the radio group item index is equal to a 0, then the first one is selected. And if we look here, the first one is the morning show, and we know that the morning shows are 150. So then if that's true, then the ticket variable is going to equal to 150. And if it's not, then it's obviously the other option, which means the ticket is going to equal to 180. Now, the reason why I say it's only those two options is because, as you can see, by default, the radio group is already selected. If it wasn't selected, then I would have to first check if it's a -1, then I would say, please select a show. But because it's already by default got one selected, they have to have one selected. They can't unselect it. They can change it, but they can't unselect it. So we know that's either one or the other. That's easy to do. So now I've got the ticket price, and now I've got to work out the total cost. If you remember, adults pay a full price while the children pay 70% of the ticket price. So that's going to, when we're dealing with percentages, we're dealing with some sort of real numbers. We're going to need to make the price some sort of real value. So let's go make a real variable called R total, which is going to be of type real. To work it out, let's just work out the basics, get the marks. So we know that the R total is going to be the number of adults that are going, which we get from the spin edit, multiplied by the ticket price, our ticket. So that's the one thing. And then we're going to take the number of children, which we're going to get from the children variable, multiplied by the ticket price. But that ticket price, they only pay 70% of that ticket price. Of means times. So times it by 70%, which is 0.7 or 70 divided by 100. You could have done either one of those. 70% of that ticket is the cost for the children. So there we go. So there's how we're working out the total price. Before I even do that though, I'm timesing it by all the children. Before I do that, I need to actually work out if there are any children that are free. So in order to do that, I'm going to find out how many groups of 2 adults there are. So that means I'm finding out how many times are there 2 groups of adults. That means how many times can 2 go into the number of adults. So that's using div. So if I work out, if I say adults div 2, make sure that you spell adults correctly. Adults div 2 will tell me how many groups of 2 adults there are. And then for every group of 2 adults, the children get 1 free ticket. So basically, I can take the number of children that we need to pay for. Remember, our children is how many tickets we want. But I'm going to change that. I want to change it to the number of tickets for the children. So that'll be the number of children that there are minus each group of 2 adults. And don't forget to put a semicolon there. And they want us, remember, they say that we must use a message DLG to display it. So that's an information message DLG. Total cost is with the value. So let's go have a look. We're going to say then message DLG. So we're going to say message DLG. And we want the text total cost is the value in R total. But R total is a real, and this is a string. So we want to convert this from a float to string, but we want to actually display it, if you can see here in the diagram, as a currency. So we're going to go float to string f, comma, ff currency, comma 8, comma 2. That's the first parameter. The second parameter for message is what type of dialog box is it? In this case, it's information 1. So we're going to say MT information. If you're not too sure, you can just type in MT, control spacebar, and you can see all the different options. And we want empty information. That's the one we want. They put that whole thing in front. You don't have to have it, but we got empty information. That's fine. And then we want to know which buttons do we want. In this case, we want just one button. If you looked at the diagram, it's just an OK button. So we can go in square bracket MBO. Okay, close the square bracket, and then we just put this 0 at the end. So remember, your buttons must be in square brackets. So there we go. And we just go semicolon. So there we go. So we worked out which tickets it is based on the morning or afternoon show. Then we worked out how many children get free. Then we took the number of adults times by the ticket price and the number of children that we're paying for times by 70% of the ticket price. And then we displayed it in a message DLG. So let's see if it works. So yeah, in this example, we can see that there are 2 adults and 2 children, and it should be that. So we got 2 adults, 2 children for an evening show. We calculate the costs, and we get the exact same number. So now if I scroll down, they give us a whole bunch of options. So we can go and test those quickly. So we can do an evening show still, but we want 5 tickets for the adults and 4 for the children. We want to calculate the ticket odds, and that is the correct amount. If we bought 2 adults and 1 child for the evening, it would be 360. That's correct. And let's try our morning show where we do 2 adults and 2 children. Calculate the cost. There we go. It seems like all of them are correct. So I haven't done the last one, but it seems like we're on the right track. So there we go. So that's 1.2 done. So let's look at question 1.3, and we're going to get a input of a ticket code via the edit control ticket code and complete the code for the buttons on click event handler that tells us if the ticket code is valid or not. And there's a couple of criteria that we need to meet for it to be valid. So the ticket code must be exactly 8 characters long. That's number one. The first 2 characters must be capital letters that are consecutive. For example, if the first letter is an A, then the second letter must be a B. So according to the alphabet. And then the rest of the ticket code, the next 6 characters must only be numbers or digits. And then the last, the 8th character, is a check digit. So the check digit means there's a calculation. So the sum of all the other digits, which means if the digits are the first 6, therefore the first 5 of those 6, if we add them all together in the ticket code, except the last digit, so we sum all those digits, the 8th digit must be equal to the sum of all those digits. For example, if we've got that, if we take 1 plus 2 plus 3 plus 0 plus 1, 1 plus 2 plus 3, 6 plus 1, that's 7, so that's going to be the check digit. If by some chance though, they say if the sum is not a single digit, if that number is greater than 10, then we just take the last value of it. So if we say, in this case, if we add all those numbers together, we get 31, and we don't put a 31 there, we just put the 1, which is the last digit. Okay, so that's our check digit. All criteria must be met in order for the ticket to be valid. Use the show message to display if the ticket code is valid or not. Only the show message messages must be displayed and no other internal messages, so we don't want any other ones. Okay, so they give me some examples. So let's first go through these criteria. So let's go to the code. There's where we're getting our ticket code from. If I double click on it, and we've already got the code and we've already uppercased it, so we check in if they're uppercase already, so that's not a problem. Now we want to check multiple criteria. So whenever I do that, I actually use a flagging technique. I'm going to make a B flag variable of type Boolean, and I'm going to actually assume that everything is correct. I'm going to assume that it's true, and the moment I find one mistake, I'll set the flag to false. So we're checking the opposite of what we want in this case. Okay, so we want to check that the ticket code is exactly 8 characters long. So I want to check the opposite of exactly 8. We want to check if it's not equal to 8. So we're going to say if the length, remember the length property of this S code variable, remember we got the S code from the input already done, if that is, it must be 8. So we want to check if it's not equal to 8. How do I find not equal to? How do I find not equal to? You remember what it is? What to the not equal to sign is? Yes, it's that symbol, shine bright like a diamond. And if it's not equal to 8, then we have a problem because it must be equal to 8. If it's not equal to 8, then B flag must become false. Then we've found a problem. I don't say else it's equal to true because we've assumed it's true. We want to check each code individually, each criteria individually. And if we find a problem, we set it to false. If we never change it to false, it'll still be true all the way through. So that's our first criteria done. Now, the next criteria, the first 2 characters must be capitalized that are consecutive. In other words, whatever the first character is, it must be, the next character must be A. Now, they've given us, I don't know if you noticed that, they've given me this alpha variable. And they say you may use this to determine letters. Okay, so that's what's nice. So if I want to find a, let's say the letter F, I'm going to find the position of the letter F. Okay, then the very next letter in the code must be the same position plus 1 in this alpha string. So for example, if we take the code for example could be BC. So we want that first letter and that second letter. So I'm going to find the position of S code. We're looking at the first 2 letters. That's position 1 and that's position 2. So I'm going to take position 1, the first letter in the code. I want to find its position in the S alpha string. Okay, so B in the alpha string will be position 2. That's going to be the position of that one. I wanted the position of the next letter in alpha to be the same as that, but plus another 1. So if I found the position of the second letter in S alpha, that's going to find the position of the C in that string, which will be a 3. So the value of this number will be a 2 in this case. That'll equal to a 2, and this will equal to a 3. That matches because they're consecutive. So the difference between the two, so this one must always be 1 more than that one. Okay, so for example, if we had, let me try another example. If I say DG, position of D would be 4 and G would be 5, 6, 7. So D would be 4, that would be 7. So it's not a difference of 1. So we want, so if you think about this carefully, we want the position of the first letter in alpha to be the same as that one, minus, we can either say minus 1 or we can say plus 1 to there. So that position, if that's a 2, we want that to also be a 2 plus 1. So to make them the same, we need to minus 1 from this one, if that makes sense. The position must be minus 1. Does that make sense? So the position of B in alpha will be a 2. The position of 2 will be a 3. But if we minus 1, they should be the same. That's how we know they're consecutive. So if this is true, then we've got what we want. But we want to check if it's not true. So if it's not the same, not equal to, if that's the case, then we have a problem. Then my B flag is going to equal to false. That seems complicated, but that's how you can do it. So you could have done that into individual variables if you want and just check that they match. But that's how we're going to use that alpha string. If the position of the first letter is the same as the position of the second letter, but we minus 1, then we know they are consecutive. So, but we're checking if it's when it's not consecutive, because if it's a problem, we're going to make it false. We assume it's true, but yeah, we find it's false. So let's go to the next one. The rest of the ticker code, the next 6 characters must only be digits. So the next 6 characters must only be digits. So we're going to come over here, and so we are going to go and check the last, so not the first 2 characters, but the rest of it must only be digits. Now we can go through individually and check each and every one, but we do have what's called a val function, which can convert a text into a number. And if there's a problem, it'll tell me where the problem is. So I'm going to actually do that. That's going to be a quicker way. So I'm going to make a variable called s digits, and I'm going to make I need to convert it into an integer. So I'm going to make it new, and I need a little check. So check. I'll explain that now if you've forgotten how to use a val. So there's what I need. I need a string and 2 integers. So what I'm going to do here is first of all, I'm going to say, hey, s digits, or only the digits is going to be whatever's left in the string. So I'm going to say copy from the code starting at not position 1, not position 2, so position 3 until the end of the string. So from position 3 until, for how many characters? 1, 2, 3. There's 6 of them. So we're going to copy the 6 characters. Now you might go, what happens if there are more? Well, if there are more, this is going to fail, and that will give it a problem. So we're okay if we go exactly from 3 to 6. Because if they do give more, it doesn't matter, because this will be a problem, and that will make it false. So we extract that number. That's all that we get in this case. Okay. So now we've extracted that. Now I'm going to use the val function. The val function works by taking a string, taking the integer or the real that we want to convert that string into. So we want to say, okay, new. So it'll take that string and convert it into an integer and put it into there. So that's my new. So that's what we're doing. So take that string, convert it into integer, put it into there. If something goes wrong, then our check will be a number that's not a 0. If everything goes fine, our check will be a 0 and it did the conversion properly. But if our check is not a 0, then there was a problem. So if our check is not equal to 0, remember not equal to, is not equal to 0, then there was a problem. Then B flag is equal to false. Okay, does that make sense? So we checked if it's 8 characters, we checked if the 2 first letters are consecutive characters on the alphabet, and then we checked that the last 3 for the last 6 digits are actually going to be integer values, or going to be digits. That is all done. Once we know that they're digits, the last character is an 8th digit. So we can actually only do this. We're going to be going through and summing all the values in the first 5 of those 6 digits. So we can do that. We're going to sum from 1 to 5 of our new string. Remember, we've got this new string called our new, or actually s digits, which looks like that. So we're going to go from 1 to 5, not 1 to 6. And we're going to sum all those values. Now just take note, we can only do this sum if this is true. If this is actually, for example, all digits. So I actually have to use an else over here. That's a little trick here. Else, begin, end. So if we get to this part, okay, this is part, we know that the last 6 digits are numbers, so we are okay there. We can't do this part if there's a letter A there. It's going to sum A, which is going to give us a problem. So we can only do this calculation if those are all numbers. So we're going to do that. So, but it's fine, because if it's not all numbers, then it'll fail over there and it'll flag it as a problem. So let's come over here. So we're going to need a sum variable and we need a loop variable. So I'm going to make an r sum variable and an r variable for my loop. And we're going to start off by initializing r sum to a 0. And we're going to loop. We're going to go for r equals, how many characters are we doing? We're doing the first 5. So 1 to 5. And we're going to use s digits because it's got those digits already. If you used s code, that's fine. Then you would have started at 3. If you looked over here at the code, you would have started at position 3, gone 3, 4, 5, 6, 7. You were going 3 to 7. So you could use S code if you want. I'm going to use S digits because it's exactly what I want. And I'm going to say rsum is equal to rsum plus the value in S digits at position R. But that is a string, which we're going to convert from a string to an int. You see, this is the problem. That code there, that line there. If we had an A there, that would have obviously been false, but if we didn't have that else, it would have done all this code with that A. It means it would have gone A, convert that, and it would have crashed. And then we would have gotten this, and that's probably why they mention we don't want other error messages, which is what would have probably popped up if we had left that open. So that's why we need to have this else part here. So we only do this calculation if they are all numbers, because we can't do that if there are letters or non-digits there. So convert that 1 to an integer, add it to sum, convert that to an integer, that 2 to an integer, add it to sum, convert that 3 to an integer, add it to sum, and that's what it's going to do. So it's going to keep doing that. If that sum is equal to the last digit. How do we get the last digit? Well, it's S digits number 6. That's the 6th one, right? This is a number, so we're going to convert this from a string to an int. If that's okay, then the check digit is correct. So we want it when it's not equal to that. If the sum is not equal to the 6th digit, then that's a problem. Then we're going to say B flag equals to false. Okay, but there is a special case. If you looked at, there's a special case. If that sum is too big, it's more than 1 digit, then we only want the last value of it. Now there are lots of ways of doing it. So before I check our sum, before I get there, I'm going to say, hey, if our sum is greater than 10, greater than equal to 10, because it could be 10, then we don't want the whole to compare all of our sum. We actually want to compare just the last digit. So we want to change our sum to the last digit of our sum. Now, how do we do the last digit? Well, convert our sum into a string and then go get the last character. We could do that, but the quickest way, so if I've got 31 and I want to get that last digit, I want the units value. If it's 67 and I want the last value, it's going to be the units value. We know that it'll always be a 2-digit, it won't be bigger than a 2-digit number because we've got 6 numbers. Well, the sum is only 5 numbers, and the biggest number we can get is 5 times 9, which is 45. It can only get bigger than 45, so even 67 is not a valid number. But you get the idea. So we only want the units number if the sum is greater than 10. And to get the units number, we want to find what's left over once we take all the 10s out. In other words, we're going to say our sum mod 10. So take our sum, let's take the 34, take out all the 10s, you're going to be left with 4. If it was 12, take out all the 10s, there's only one of them, it's going to be left with 2. So that's how we get that last digit. So we're going to change our sum because we're comparing our sum over here. So if our sum is greater than 10, then change that our sum to whatever our sum is with all the 10s out of it. So that's how I do the 2-digit number. So that's the only tricky part. If you didn't get it, then at least if you left that line out, you probably would have lost 1 mark. But that's what we do. So let's double check. We checked if it's 8 digits. If it's not, it's a problem. They're not consecutive, it's a problem. We did val and we checked if those aren't all digits, from the 3rd character to the last character, then it's a problem. Then if they are digits and we add all those digits from 1 to 5 together and it's not equal to the last one, it's a problem. But if it's greater than 10, we just get the last value and we check if that's equal to the last digit. And so if we get to this part over here, if we get here, so this is after that. After all those checks, if B flag is still true at this point, that means it went through all those checks and never became a problem. It never failed one of those checks, which means it's met all the criteria. That's why we check if it didn't meet the criteria, change it there. And that's also why we don't use an else B flag equals to true, because if B flag equals to true here, if we did an else B flag, then it just needs to meet the last criteria and then it'll be fine. But we want it to meet all the criteria. We assume it's true, go through, do all the checks. If we get over here, if B flag is equal to true at this point, that means it went through all those checks and there were no problems. Then we want to have a show message that just displays valid. And if it's not, we just say invalid. If it's true, then show message valid. Else, if it's not true, then show message invalid. Okay, so there we go. So let's test it quickly. Let's test it. Let's run it. So let's take this code that they said. B and C is consecutive. It's 8 characters. 1 plus 2 plus 3 plus 1 is 7. So that's all correct. And it says that it's valid. Now, if I change that last digit to an 8, then the check digit is incorrect. That's a problem. If I change it back to 7, but I change this B to a S, BS. Yes, it's BS. It's not going to work because it's not consecutive. Now, if I change one of those letters to an A, it would go invalid and it stops. You see how it stopped? I'll show you if I took that else out what it would do. If I change that back to a 3, but then I put another digit over here, it gives a problem because it's not 8 or more. Okay, and they give other options over here. That's also a valid option, so I'm going to copy that one and put it in there, and it's valid. But all of these are not valid, so that's not valid. Let's do that one. Yes, that one's invalid. So there we go. So it's working. So if I just remind you, if I didn't have this else here, if I took that out and I put a semicolon there, you'll see here, this is where the problem comes in. That is all correct, but if I change one of those to a letter, which means that is going to be false for a digit, but it's still going to do the check digit calculation. See, A is not a valid integer. That's a Delphi error message. So that's what's causing it to pop up, because it's trying to convert that from a string to an integer, which is giving it a hassle. That's why we must have that else there, and that's why they mention over here only valid or invalid, no Delphi internal messages, because that's an internal message for that. So there's the 17 marks. Okay, so we're happy with that. So there we go. So let's move on to question 2 now. Make sure that you check the video description to access the data files as well as the links to the other videos in this video series. Make sure you click on the subscribe button on our YouTube channel, leave a like, leave a comment. We would love to hear from you. And remember, don't do it the long way, do it the Mr. Long way.